Yes. Okay. We are
Nice.
recording now. So this is the Dutch Clojure meetup number, I think 125, which means 125 consecutive months of Clojure meetups in the Netherlands and as of late in the interwebs. So that's what month is it? It's May 2020. It's a full COVID um, period here, so that's why we are having with the online meetups, which actually is not so bad. We didn't have that much action going on our YouTube channel thanks to the latest recording. So hopefully tonight as well is gonna be great content for the present people and the future Clojurians coming by in our YouTube channel. Tonight we do have one person that kindly agreed to share something interesting with us, and I'm gonna leave the stage to Andrea. I guess you are the best one to present yourself.
Yeah, thank you, Carlo. So I'm Andrea Crotti. I live in London and work for a company called Funding Circle with a few offices around the world. And we do loans to small and medium business. Uh, what I'm going to talk about tonight is related with Kafka and Clojure, because we are kind of quite heavily invested in these technologies. And there are two main things I will show you. One is called topology-grapher, and the other one is called Jackdaw. If you use Kafka in Clojure, you might have heard about Jackdaw, and probably not about the other project. But I'll just explain. So Jackdaw is a library for Kafka in Clojure, so to make it more easy to interop without having to do all the Java interop yourself. And it is composed of many things. There is an admin API, there is a streams API, and maybe the most useful thing of all is probably the test, the Jackdaw test code, which allows you to write tests in a much nicer and easy way. But that's not kind of the main topic of the conversation here. I will use Jackdaw though during the examples, so that's why I just want to introduce this. So we've been using kind of Jackdaw for 4 or 5 years, and since like some time ago, one of my colleagues came out with the idea of actually trying to have a visualization of all the topologies that we have. And if you kind of work with Kafka in any company, sooner or later, when you have microservices as well, then things start to get really complicated, and you have a lot of different services writing to different topics, and no one knows what is going on anymore. That's kind of a common issue. So things like questions like which services write to this topic, or what actually read from this other topic are quite common, and somehow it's not easy to find out most of the times. So the thing which the idea kind of my colleague had in the beginning is that there is something when you have a topology object in Java, or well in Clojure in this case, at the end of the day you can call something called describe, which generates a description from this object. And at that point, the interesting part is that nothing actually runs. So you don't need even have to Kafka running. You can just generate this object kind of manually in the REPL, as I will show you in a bit. So that means we can, that's where the idea came from. And that means we can actually generate some graphs from these things, from these topologies. And then we can also merge these graphs together and make kind of a massive graph of the whole company topologies. And that will allows you to actually see the whole graph about the whole company. So that's where the project came from. So this part I'm going to show you today is a library which is called topology-grapher, and it's the most the most important component of this project, but it's not the only thing. What this library allows you to do is to actually generate these graphs by defining topologies in your project, then using some simple calls and simple transformations, and I'll show you in a bit to to actually generate some EDN files. These EDN files contain all these graphs. But the other bit, which I will not show today because it's not open source, is the way that you actually integrate the whole thing. So the way we do it is that we actually generate these EDN files in each project separately. Then we push them to Circle CI automatically for every build. And then somewhere on S3, we collect all these things. Then there is another project called Topology Viewer, for lack of a better name, that actually takes these things and displays them all, allowing you to kind of select multiple things, join these graphs, or do queries like what happens if who actually uses this topic, and then it filters out the graph dynamically, showing you all the services that do it, that kind of stuff. So you can use this library, however, by itself, even directly, just by embedding in your project in the dev profile, for example, and you can still generate a graph with all the topologies you want in the project itself. So it is still useful to you by itself. So I just wanted to explain what was the kind of a bigger idea. So if you have any questions, by the way, you can stop me at any point, because I don't know if it's talking anything. So if you look at the project itself, it contains the usual files, a depcdn file, and then there is documentation, which I hope is more or less clear. But if you kind of try it and you struggle with anything, please let me know, kind of open issue or anything. So there is a tutorial, then there is some examples. This is how kind of a simple graph looks like. And then there are some more internal implementation documentation. But let's actually have a look at the real demo. There is also some documentation of how to integrate with Circle CI, for example. That's kind of really optional in a way. And it only makes sense if you have something that uses this information, otherwise it's not very useful. So let's go to an actual demo file, which is part of the project itself. So you will find it in the project. So in topology-grapher, there is, can you read, is it too small?
No, I think it's good enough.
Yeah. Okay. So there is a directory called sample project, and this project is actually a real project which just uses the topology-grapher with the local paths. So it's kind of easy to, if you do some changes, you can try them. So the file which I'm going to open is a demo file, which allows you, which is where I was going to do some fun things to try out things. So I evaluate. So here at first I require all the different things I need, and it's just two namespaces from topology-grapher and two from Jackdaw. The ones from Jackdaw are used to define the topology in a way that kind of easy to do, but just to be clear, you don't have to use Jackdaw at all to use this library. You can also use directly. There are some examples of that in the project, some tests. You can just use the normal Java interop. In theory, I guess you could even use this library with a Java project if you kind of do the right magic. So I just evaluate this. Then the first thing I need is some way to define a configuration for the topic. It is needed to for Jackdaw later on, which if I evaluate is simply kind of a map with the name, and you have a few things, the third here. Then let's define the actual topology. But first, this is a function, a transform function, which if I just call it directly here, you can see that it's simply a pure function that takes like a map and returns another map. This function here is actually used in the definition of the topology. And I just want to point out that in general, the important thing, the nice thing about Jackdaw is that when you pass functions to filter or map values, you don't have to worry about having to do interop at all in that stage. You can just pass pure functions, and then you can test these pure functions separately. You can do all sorts of stuff. You don't have to worry about the. So So the topology I'm defining is really trivial. It's not very interesting, but what it means is that it reads something from an input topic here. Then it filters out all the values that were enabled is true. Then it transforms these values with this transform function. So just by incrementing this number, and then it writes out everything to output. And the other thing you should notice is that it takes a builder as input and it returns a builder. That's just the way you kind of modify a builder object in Jacto, while in Kafka in general, to kind of add, to make it a real topology. Any questions about this? I know it's a bit, if you've never seen Jacto, it might be a bit, but it's just the simplest example I come out with. It's like you filter, you map, and then you write out. It might be more clear when I show the actual graph, maybe.
So one question.
Yep.
So the builder is a mutable thing because you're using a threading macro and then return that same thing, right? So it's kind of like an atom or something, or?
Yeah, it is definitely mutable. I don't know how it's implemented. It is kind of, it is a kind of a Java object kind of thing. So
right.
Yeah. So I don't really have to kind of worry about that. Yeah, so the metadata is something that we need to categorize the graph itself when we kind of generate. And this is only useful, again, if you are going to merge different topologies together at some point. So even if you do it locally, you might have like 2 or 3 different things you want, and then this allows you to group things. But it's not very useful, I guess, if you just do one. This other thing is just a helper function to generate an actual topology object. And I'm going to show you here, which is maybe more clear, what are the different types involved there, because it is a bit unclear otherwise. So first we have a stream builder. This is a Jacto kind of interop CJS stream builder, which is a wrapper around the Kafka stream builder. If I then call a function T1, which is the thing I was just explaining, on this stream builder, again, I get another stream builder, which now has actually a topology attached to it. Now, if I call this function, this helper function, I get instead a topology object. And that's the important thing which we want to use to actually extract the information we need from Kafka, because Kafka already has the ability to do this graph in a way. And if I call describe now, as you can see, it is already kind of, it returns like an internal topology builder thing, but it also prints out as a string some kind of graph-like representation. We don't actually use this graph-width representation because it's not kind of complete enough or anything, but we just loop over all this description thing like a graph to generate an EDN. So that's kind of how it works. Then we define a vector of topologies, which contains a topology object here, and then just the name of the application, which can be anything in this case. At this point, we almost have everything kind of set up, and we can generate a topology EDN. Topology EDN, it's actually a big map which contains the graph representation, where it contains like the metadata here, an ID, which is useful then when you merge things together, and then a graph representation with the nodes and the graphs of what's actually the internal topic, the internal representation of the topology. So if I now actually call this function here, if I render the graph and I pass these options, mode topics, cache faults, and I open this file here, you will see that it generates this incredibly uninteresting graph, which, however, still shows you kind of there is an input topic, then there is something happens in the middle, and then there is an output. If I do something slightly different here, and I do more detail, and then open this one instead, it gets a little bit more interesting because it actually kind of shows you what are the inner working of this thing. So you can see there is like a source, then there's a filter, map values, and then sync, and then the overall thing is still my application ID. So that's how kind of easy it is to generate a graph from the topology object. So the only thing that somehow, well, that you have to take care of is that your project is kind of set up in a way that you can actually extract these topology objects without even running anything, which is the important bit. The only difficulties that we had in integrating this library was in the projects where this wasn't true. So where like everything was tangled together, like one was just the component library, for example, and so nothing was initializing without actually the whole thing running. So if you don't have this thing, then it's really easy to do, and like you just can put it in like a Circle CI thing and generate the scripts, or you can do it locally from your dev environment. So now, if the more interesting thing is to actually merge multiple graphs together, and that's what you do. You can do it inside the project itself, where you normally will have multiple topologies, or you can do it across projects. So if I add another topology here, and then I set this other thing, and this topology simply reads from the output of the previous topology as input, and then writes to another final topic. Then I do the same thing, and then I render the graph. Here we get a combined graph of the two things. And this combined graph now is still with the detail mode. When you actually have a lot of topologies that are very complicated, the important thing is not to see the internals because it gets really messy. But then by default, it would do just like topic mode, and then you still see the flow, but you don't have to care about what's inside. Other thing, which is maybe interesting, is that you can use different formats. You can do like dot, so you can render the graph width file. So if I open this is the actual graph width file that is used to generate the graph. So it means you can, in theory, kind of generate it and manually change something if you want to use it to present, for example, something, but you don't want to. You want to cut something out. You can just do that. You can have a PNG, maybe even EDN, if I remember. No, EDN, no. So yeah, PDF, PNG, and dot. Last thing about this demo is that you can also generate a zip file which contains all these generated EDNs files, and then so there is one for each topology at the moment. So why is this? It is useful when you actually do the thing I was talking about before, when you generate something at build time, and like in your CI, and then you push it somewhere else. So you just generate lots of zip files, and then something else will read them, merge them all together in one big thing, and then you can do all the different manipulation of graphs and merging of different graphs quite nicely. That's kind of all the demo I wanted to show. But if there are any questions, I'm happy to answer. Or just one last thing. I mean, there's a lot of different possibilities for the future to do things. One nice thing could be, for example, you can diff a graph. You can have like something in GitHub that automatically takes the master representation of the topology, and then it compares it with the one in the current PR that you have, and then it shows you kind of a nice diff. So you say, okay, so this is how your topology change. Or yeah, the other important thing is to allow you to query things, like say, oh, who read from this, who write from that. This is maybe more of concern for something that's not this library itself, but there is some of the code to do the actual analysis is here in this project, and it's actually using Loom, the graph library, to extract some of this information, which is something I want to use more, like to actually for the whole representation of the graph. And eventually, if we have that, we can use all the graph algorithms available there to do some sort of all the possible things we want. And yeah, that's it. That's all that I wanted to say. Any questions?
Yeah, you mentioned you can see the diffs of the graphs. How would that look like?
Yeah, that's well. I didn't say we can see it now. I said it's kind of one of the ideas for the future.
Okay.
But the way there are two options, I think. One is to actually generate the graph with representation of the graphs and do a text diff. So that wouldn't be that wouldn't be very very graphical, I guess. But you can still at least you can still see what are the things that are changing, and it's kind of nice. It's a nice text diff that everyone can understand, I guess. That's one way. The other way is to actually somehow using maybe the Loom library or something like that, you can still probably easily find out which nodes are in one graph and not the other. And you can color them, for example. So yeah, I can have like the final graph, which is in my PR, and then I have the master graph. I see which things are different, and I assign a different color to things that are different. And that's kind of a nice representation of the differences. That's kind of two possible ways. They're not really hard to do. It's just I haven't actually done that yet. But yeah, that's another possibility.
Cool. Thanks.
Sorry, Andrea. I joined later. Like, what is this? What are you using this topologies for?
In what sense? This is well, what I was talking about in the beginning. I was just explaining that the library. Now the topologies are Kafka topologies. If that's what you're asking. That was clear, maybe. So this it's what I was talking about. Is a library called topology-grapher, which allows you to generate graphs from Kafka topologies. Is that more clear?
Yeah, thanks.
Okay.
And can you maybe repeat how are you using this project in a more real life?
Yes. Sure. So yeah, this library you can use it by itself. You can just include it in your kind of dev project CLJ dependencies. It doesn't really have many dependencies itself. Well, this one is kind of scope provider, so it just assumes this there because it needs to be there. And then there is CLJ UID, tools CLI, and Loom. Maybe it's the only bigger one, but it's not so much. So if you include it in your dev profile, you can just generate these graphs locally in your REPL and see how your topologies look like. But the bigger idea, which is what it was kind of the aim of the long-term aim of this project, is to be able to have the whole representation of all the topologies in a company. And to do that, one way, which is what we do, is to have every project generate these zip files with all these EDN files containing the graphs generated to S3, and then something else is able to kind of fetch everything, merge, mix and match, and allow us to do queries and say things like, what's the flow of this particular, how does this microservice look like, or what happens if I want to know everything that touches this particular topic. So it can show you like all the different microservices that read or write a specific topic. So you can, once you have the information, you can do all sorts of interesting things, I believe. And it's it's been kind of a constant issue at Funding Circle, at least to be able to know who writes to what, who reads from what. So that I don't know if that other people have the same problem, but we have it quite a lot. So that was the main goal. I don't know if that's more clear now.
Yeah, thanks. Yeah, my experience of Kafka, we were just a small, tiny company, one single team, so we didn't have this problem probably.
Yeah. Now we have maybe more than 100 developers, and hundreds of topics for sure.
It would only be useful if you use Kafka streams, right? Because in my current company I'm currently working at, it's mostly just Spring Kafka. We just lose consumers and producers.
Yes,
Topology.
Yeah, good point. I didn't mention that. We use Kafka streams more or less everywhere, so I forget that it's not the only way to do it. But yeah, you could still, I guess, maybe find a way. So one thing which is also not great, I think, is that a lot of these interactions between different projects actually happen through things like Kafka Connect, because you write to some database tables and then something else reads from the topic, and that is actually something that this tool or this way of visualizing things would miss. So in theory, I was also thinking about how to add this extra stuff.
Yeah, it would maybe be nice if you could have like a pseudo topology based on the current use or something, but that's quite hard to figure out because then you need to use your producer or consumer's IDs consistently or something like that to match them. But something like that would be very nice.
Yeah. I mean, definitely open to suggestions in the project. If you want to have any ideas, you can open an issue or.
Yeah, but correct me if I'm wrong. I think you can produce the topology in an easier way, rather, because can you create a consumer to Kafka without actually connecting to Kafka?
No, but you don't need a topology for it. If you just have a loose consumer and producer, you don't have a topology that you upload and use in streams, and it's just one thing and the other one aren't really connected for Kafka. One is just consuming and the other one is just producing.
Yeah.
And if you don't give them the same ID and you don't need to give it the same kind of ID, then there's no way really to match them.
Yeah, and that's fine. My point being that what I understand is that you can generate the topology object without connecting to any running Kafka, whereas creating the consumers and producers, you need a running Kafka to create them, right?
So it's kind of like the topology is kind of like your blueprint. So you can also run tests against the blueprint and stuff like that. So you don't need a running Kafka.
Yeah, I think that's correct. I mean, the only way I can see that this could work with the producer and consumer is that if you're using kind of a library that keeps track of these things. Somehow, if Jacto kind of knew, if you only use Jacto in the project, and somehow he kind of kept track of all the things you're doing, and then you could ask Jacto what's who writes where, but yeah, it's definitely more tricky. I guess it's not as simple.
Yeah, we do have the current problem that we don't really know from the topics who reads from it and who produces. Mostly it's trivial, but even that is not always trivial, and it's becoming more and more problem as we use Kafka more and more. So yeah.
Yeah, probably you need to have some sort of a runtime component that analyzes what your application is doing, and you probably need some layer in between that keeps that does the bookkeeping of what producers and consumers you have in your runtime and exposes that.
That's one way, but I hope that we go away with using access control lists, because that's also supported by Kafka, and then just by using that, and you can also query on that, and then based on that you could also you just know who has the rights to read from a certain topic.
Yeah.
But we're not there yet.
Question to Andrea. The format that you use to describe the graph, is that a format that you invented, or you inherited from Loom or something?
No, well, neither, I guess, because it's what my colleague originally invented.
Okay.
It's yeah, one thing which I want to do is to convert it to actually use Loom. The only reason I haven't done it is because it just takes a bit of time to do the whole thing, and the problem is that at the moment it's kind of, so if I use Loom, it's a bit more tricky to find how to say to graph it. Oh, this is a cluster. This is this that, and I have to add that metadata into Loom somehow. And well, I mean, it is possible. I just haven't found a way yet, and I just need some time to do it. Because I mean, this format is fine. Actually, I am partially converting this format into Loom in one of the files here. I think this one. Yeah, so it is transforming into Loom, just the graphs and the edges, because to actually do some analysis on the stuff, because it was easier that way than using this format. So at some point, I can just kind of use Loom directly and not having to do this sort of stuff. But there is also already kind of a capability to transform it into Loom and to use the Loom algorithms.
Okay. Does it round trip? So can you go from topology to your description of topology to Loom and vice versa without losing data?
Yeah, no, that's a problem. Otherwise, I would have kind of done the whole thing already. I mean, I lose few. Well, I lose probably kind of this metadata, but I lose also other stuff like the type here. I just haven't kind of done a full migration yet. So I just did the minimum I needed to actually be able to fetch things like boundaries and a few kind of other things I needed. But yeah, it's not done yet.
Okay, clear.
Another thing which is maybe useful is that, well, not everything, but the topics and analytics files are CIJC. So these are actually used in the project in Clojure script because they kind of allow you to do some analysis and some things on the graphs. So that's also kind of useful. If you kind of want to write your own front end for this stuff, at some point, maybe I'll be able to actually open source what we have. The only reason it's not open source is not really because of like we are scared of releasing it, but it's just because we have in the project itself all the things to deploy it. It's like an internal definition of configuration files to be able to, and there is some specific funding circle things that it's a bit hard to take out, or could be taken out, but it's a bit tricky. So if eventually we manage to make it non-funding circle related, then would be happy to open source. But if you want to write kind of your own simple UI, you just have to. You can use most of the kind of logic here to do the heavy lifting, and in the UI project, you just have to call the different render things and then return the image. And it's not that hard, really. It's kind of most of the work is done by the library.
Okay. Would it be possible to have an SVG output? My thinking is if you have SVG, you can create a fairly fancy web front-end to it.
Yeah, well, actually, yeah, Graphic supports SVG, so yes, it will be probably trivial to add. Actually, yeah. Is it working already? Maybe it is already there. I can check because I never really use SVG.
I think Graph
it's not there at the moment. Yeah.
Gui, please, what did you say?
I was saying I thought that Graph is rendered to SVG by default, and that the PNG was actually an option on top of that. But obviously this implementation is different.
Yeah, it's possible. I mean, I just haven't used it. I probably just have to add like a line of code for the supported format, and then it works.
Yeah. Because I'm already dreaming of an interactive graph when you can click the boxes and see things.
Yeah. That's another thing which I was also thinking about. Maybe I think at some point graph is not enough anymore in a way. So the graphics is very good to kind of generate these things easily, but if you want something a bit more dynamic, it might be hard with graphics. There are probably some JS libraries which you can use. So if in theory you are able to convert from the graph to the format which kind of some sort of JS library is capable of understanding, which does all the graphing, then you might be able to do some really cool things.
Yeah. All right. Do we have any further questions for Andrea? Three, 2, 1. No. Okay. Thank you so much, Andrea, for your presentation. Much appreciated.
No worries.
And just a side note, I've been keeping track of a few of the projects or topics that we mentioned, so that I can add that as notes in the YouTube video once I upload that. If you have anything else that you would like to share there, just let me know. All right. So at this moment, we do not have anything else scheduled in our agenda. Is there anybody else that would like to share something with us? Maybe?
I could share something, but if you still have time and energy to.
Well,
there is no one else that wants to, because I've shown enough stuff already this year probably. But if there is nobody else, then
I would say the amount of things you're producing in the past couple of years is worth of more space than what the Meetup has to offer. So go ahead.
All right. Let me share my screen then. Let's see. I haven't actually prepared anything, but I'll just keep it short. Let's see. Can you see my screen now?
Yes.
I'll put this aside. Else we get into some kind of Drost effect. Let's see. So I want to tell something about a feature that I added last 2 weeks to Babashka. And Babashka, for those who do not know it, it is a tool to execute scripts, Clojure scripts. But instead of on the JVM, where you get like 1.5 seconds, 2 seconds startup time penalty, Babashka is very fast. So let me just do a quick tiny demo for those who don't know it. So you type BB in the command line. So BB is short for Babashka, and then you can do an expression like +1 to 3, and then bam, it's very immediate. And you can define functions. So this is a function that returns foo, and when you call it, it returns foo. You can do macros, you can do namespaces, multi-methods. There are a couple of limitations to Babashka. It doesn't have protocols at the moment, and it doesn't have reify, but those are and dev records is also missing. So those are the limitations at the moment. And I must say that the dev protocol is the most common thing that you will bump into when you try random Clojure code from the internet. But it does already support quite some normal Clojure libraries that were not written with Babashka in mind. So it is capable of quite a large subset of normal Clojure programs. So there is also a README page about what libraries are currently known to work with Babashka. So there is a SailJ HTTP library that works, and Babashka has a class path. So you can say, I want this library on my class path, and then you just use some other tool to do the dependency stuff. So here we use Clojure to download the SailJ HTTP library, and you get a class path, and then you can run it with Babashka. So there are a couple of libraries that work with Babashka. So, and Babashka also has a couple of libraries built into it. So then you don't need any additional class path settings. It just has all these namespaces. So there's a list of them here. So you have Clojure string, set, Eden, tool CLI, data CSV, data XML, Cheshire, a YAML library, and I have to remove this one probably. Oh, well, it's available under a feature flag, so this is not available in the normal Babashka. But this there is one problem that I've been thinking about with Babashka, because the longer this tool will exist, the more namespaces will be added to it. And so far, I haven't regretted anything that I've added to it. I think this is all useful for scripting. But in the future, there are going to be people who will ask, hey, can you add Loom to Babashka, or can you add my favorite other library for dealing with HTML or something, JSoup? Can you add that to Babashka? And can you add this? And can you add that? And I would, in theory, I would like to Babashka be as powerful as possible. But I also have to build it somewhere to be able to distribute it. And these build environments are memory constrained. And Babashka is built using a tool called GraalVM. And GraalVM produces binary from Java class files. But GraalVM requires quite a lot of memory to produce this binary. So so far, I've gotten away with building on Circle CI with, well, a couple of months ago, it was 4 gigabytes, but then that wasn't enough. And I got some help from Circle CI to make available some more memory. But eventually, I will hit some limit again, where I have to stop adding stuff to Babashka, or I'll have to make like a custom build environment for myself on, I don't know, AWS or something with a lot of memory, and then it won't be free anymore. So then I want to be able to provide Babashka binaries for free. That would be the most ideal situation. So then I have to find a way how to run it still on Circle CI or GitHub Actions, or there's also a Windows build environment that I'm using. It's called AppFair. And there's also another problem with adding more and more stuff to Babashka. It's the binary size. Let's see. So it's binary is here. Let's see how big it is. It's now 48 megabytes. But if you add more and more and more libraries to it, it grows. So eventually it becomes maybe 200 megabytes, and that might still be okay for some people, but maybe someday it becomes also too big to download. So it's quite okay right now, the downloads. It's, let's see, it's only like zipped. It's very reasonable still. So let's see, the Mac OS binary is only 13.4 megabytes. So it's like a few seconds and you have it. But it would be nice if we could have a way to make Babashka, like extend Babashka with optional features instead of putting everything inside this binary that everyone downloads, because not all features are also useful to everyone. So it would be very nice if we could add something optional to Babashka that people can download as some kind of plugin or add-on thing that you can run together with Babashka and still have this fast startup time. So the first thing I did was I worked on some feature flags. So you can see that here in the project CLJ. So there are all these features. So you can compile Babashka with or without all these features. And XML is a standard feature, and YAML is also a standard feature. But JDBC is not included by default, and the Postgres driver is also not included by default. But if you want, you can turn everything on and then compile a version of Babashka yourself. So that was the first thing I came up with. And here is you have a data script feature. Data script is like 40 megabytes extra if you want to include that. And it also requires a lot of memory to compile, but it works. So then you can compile like a bigger Babashka for yourself, and that works. But then we also tried another approach, which was add support for dynamic native libraries. So you could compile a native library in C or C++, or GraalVM also supports this. And then we could load this from Babashka, and then you could call functions from this dynamic library, this native library. So we tried this. Let's see, native libraries. There, I had an issue about this. Yeah, so it was like an experiment, and I experimented with it, but I got a lot of segmentation faults and stuff like that. And eventually I thought, well, this isn't going to work out. Even if I can make it work, it will be a big headache to maintain this. But then I thought, well, it's already possible to shell out to other binaries and if those other binaries can return something like Eden or something, that's already quite powerful. So if we can communicate via Eden in, Eden out with some other tool, that's already great. And that's basically what the new idea became. And that is called pods. So pods is a idea to create different command line applications that can communicate with Babashka via a simple protocol. And the protocol, Babashka talks to this other command line tool via standard in and standard out. And there is a small like protocol so the pod has to declare what functions it has, and if the functions are asynchronous or not. So that's basically it. And so maybe I can just show an example of what one of those pods. Oh, I see the formatting is not good here. So there is one pod. So pod is basically an extension to Babashka using a simple serialization protocol using Eden or JSON. So here's a demo. So in Babashka, you just say, well, I want to use a pod. So you need the pod's namespace. And here you say, I want to load the pod. And what this does, it spins up this external binary. And it keeps running for the entire duration of your script. And this binary can declare namespaces and vars. So this is a namespace that this pod declares. It's a similar name to the binary itself. And it's just a normal namespace from now on. So now you can create a HSQL database that is managed by this pod. And you talk to it via Eden. So these arguments are serialized to Eden, and then they are processed by the pod, and then this is the response that comes back. But it just looks like normal Clojure code. So if I have this pod also on my machine, so I can do a live demo. Maybe. Oops. So this is a Babashka REPL. See. Oops. Okay. So now I want to load the pod. The pod is somewhere on my path, so it knows this binary. So I will show that as well. Which pod? It's installed here. So you just provide the string and then it finds the binary on the path. But you can also give it a full path if you want, or command line arguments even. So it can be any binary implemented in any language, but this pod was implemented also in Clojure. So now I will require the namespace that is provided by this pod. Now this is just some data that declares what the database should look like. And now I'm executing some SQL against this pod. It will tell me, oh, this worked. Now I will insert some data. That worked. And now I will fetch some data from the database. Oh, that also worked. So it all works more or less seamless. Once you have loaded the pod, you can use these namespaces. And Babashka doesn't have to suffer from extra baggage of all these dependencies. So let's see. I can show you how big this binary is. So this is 20 megabytes. So I just saved, like, if I would add HSQL DB directly to Babashka, it would add another 10 megabytes. So there is some overlap of what is in this binary and also in Babashka. So it's not literally saving 20 megabytes, but it is significant. Maybe I'll show one more pod and then we can have some questions or stuff. Or if someone already has a question, that's also fine. Just shout.
I think before jumping to a different pod, I would like to see how the pod that you just showed is implemented in terms of implementing the protocol, at least. You know?
Yeah. Okay, that makes sense. So yeah. So this is this is all the code that is required to write the pod. And it's basically, it's a Clojure program that has just one main function, and it ignores the command line arguments. So it just runs in a loop. So it listens for input and it reacts to this input on standard in. And here it tries to read from standard in. So this is the read function. And what does the function do? It reads Ben code from standard in. And Ben code is a really simple protocol that is used by, I think it's used by BitTorrent originally, but NREPL also uses this protocol. So what NREPL does, if you, I think most of Clojure users know NREPL. It is a protocol to talk from your editor to a REPL. So your editor can send commands to a REPL, and the REPL then executes some code and sends back a response. So that's exactly the same model that I've adopted for pods, only slightly different. The messages are slightly different, but the idea is exactly the same. So the messages are encoded in Ben code, and Ben code is a really simple data format that has only 4 types. And on top of that, you choose either JSON or Eden to encode like more complicated values, like sets, or the function arguments are encoded in JSON or Eden, and the function return values are also encoded in Eden or JSON. And the reason I didn't choose JSON for like everything is that I want to keep some flexibility of not forcing JSON on all the pods, or not forcing Eden on all the pods. So Ben code is like a really minimal base requirement, and the rest will be optional, or one choice out of many things. So so this pod tries to read from standard in, and then it just looks at the message, and the message has an operation, and so here it dispatches on this operation. And this pod has 3 operations, but most pods only have to implement describe and invoke. And shutdown is a special one here because we're dealing with a database, and this pod needs to be able to shut down itself, because there is some shutdown hooks that SQLDB has. So if I would kill the pod abruptly, there would be like logs still on the database, and the next time you would invoke it, it would take longer for it to discover that the logs are actually not used anymore. So that's why it also implements this 3rd operation, but normally you don't have to do this. So the describe option is the first one, and here this is just like saying, please describe yourself. In what format do you want to send the payloads? So here the payloads are formatted in Eden, and also you have to tell what namespaces and vars this pod implements. And also here you can say, like, I implement these extra additional optional operations. So if the pod says I also implement shutdown, then Babashka will send it a shutdown message, and then the pod will clean itself up, but it's optional. So this is a namespace and this is a var. So I just showed like the execute var, and so here it is declared that it exists, and so Babashka knows I can invoke this. So what happens if you invoke it? Well, then the pod receives an invoke message, and it tries to decode the arguments using Eden, and then it looks up the right var you want to invoke. So there's a small table here that just looks up the right function, and then it invokes the function and it sends back the result. So the result is value, and done just means this is the last reply about this invocation. So each invocation has an ID. You can send multiple messages back that are related to this ID. And this also allows to implement asynchronous functions, because potentially you can receive the value back at a later time or multiple values at a later time. So does that shed some light on how you implement?
Yep.
Yeah. And there's also like a message for dealing with exceptions. So if an exception happened here, we just catch it and we print it to standard error. And then we send back also a message that represents this this exception. So we have a message and we just print back a map with some information. And if you send this back, then Babashka will rethrow this exception, let's say client side. So if I do something silly here, I select from bar, which is a table that doesn't exist, I get a real exception. So this is really the exception that came back from the pod and then reified as a real error. So so maybe one other pod, like a totally different one, is a file watcher pod, which also implements an asynchronous function, which could be interesting. So so this one is built in Rust. So that is just to show that it doesn't have to be all Clojure. It's language independent, just as long as the pod can return the right values, basically. And also Rust has really good file watcher libraries, and it's very good at this low-level stuff. So it's nice that we can do this in a different language than Clojure. But I have to say that dealing with this heterogeneous data in Rust is a bit more painful than in Clojure. So yeah, but that's just life. It's static typing and data. It's always a little bit, well, not so nice as in Clojure. But so this is Rust code which does the file watcher thing. So here we dispatch on invoke again, and here we say oh, we want to watch a file path, and here we basically start a file watcher. And what happens is, so this is some library that has the file watcher functionality, and here we just it's started in its own thread, so you can have multiple file watchers in the pod running simultaneously. And what it does, it sends back values, but on the Babashka side, this looks like a core async channel on which you can receive values. So let's look at that. Okay, so I do the pod thing again. Okay, let's see. So now I do load pod Babashka file watcher. Okay, this is just a detail. You can ignore this. But, So now I must require the namespace pod Babashka file watcher as fw. Okay. And now I can watch a file, watch a directory. So let's do that. So what you get back, yeah, of course, because I now I entered a path that does not exist. So this is just output from the pod, like, oh, I don't know. I hope it's still running. I'm not sure. So this is also a thing you have to be very careful when you implement a pod, like that you can survive these kinds of errors. Okay. I think this is a debug statement because of some local version that I have around. But so here I'm watching the temp directory, but actually I didn't do anything with the return value, so I have to save it. But we can spin up multiple watchers, so there is no problem. But it's just something running in the background right now that we haven't got control over anymore. So let's call this Chan. So it's a core async channel. So now we need to require Clojure core async to read from this channel. So let's read one value from this channel. So this will block the current thread, right? So now it will wait until we have a file watcher event that's coming into our channel. So let's try something. Maybe I already had this file. Let's see, foobar1. Oh yeah, so there it is. So we got one event on the path foobar1, and it was of type created. Let's try it again. But let's like write something maybe to this file. Now we get another event, which is notice write. So, but there is, when you write, you get from this library, you get two different events. I'm not entirely clear what it means, but I just propagated it to the core async channel. But at least you get these events, like someone wrote to this file or this directory. So that is how a asynchronous pod function looks like. So to summarize, pods are a way to extend Babashka with functionality that is potentially coming from other languages or a Clojure ecosystem itself without building it into Babashka itself. And one other interesting fact is that you can also use this from the normal JVM. So you don't have to use this with Babashka. So if you want to use the file watcher pod from the JVM, you can also run it using this library. So that's all I have.
It's actually a lot. I do have a question, and so you say that Babashka spins the other binaries in the background, and
yeah.
Just to confirm, so those binaries are kept running until the Babashka process runs, right? And then they are automatically cleaned by Babashka itself.
Yeah. So if I now do ps grep file watcher, there is one pod running because I started it here with load pod. But if I kill this process and I do it again, then the pod is gone. So Babashka starts the pod and also cleans them up when you exit the script. And this is because the pod is kept running for the entire script, because it would be very time consuming or wasteful to start it for every function call. So that's basically why this is done that way.
And for some other things, stateful interactions, it's probably the only way.
Yeah, right. So pods can have state, like the HSQLDB thing. It has state, obviously, because you can do an in-memory database. So, yeah.
And even the file watcher, you have the current threads running. So.
Right. Yeah.
Cool. Have you had the chance to use the Babashka pods library out in a JVM Clojure JVM project to integrate with, let's say, other programs written in other languages?
Not yet. I do use it for. I do use the JVM library for testing the pods themselves. Mm-hmm. So I can do my shells. Yeah, I'm still sharing my screen, right?
Yeah.
So let's see. If you go to the file watcher pod. So if you go to the test directory, so this is just using the pods library, and I run these tests on the JVM, just using normal Clojure, no Babashka things. So, so I'm calling the Rust code from Clojure basically, without writing any JNI stuff. So.
That's thanks to GraalVM, or?
No, GraalVM is not involved in any of this, because it's just Clojure calling Rust.
Yeah. Okay.
But by spinning up like a separate executable.
I see.
Let's see. So the file watcher actually is very small, because Rust is very good at producing very small binaries. So this is only 800 kilobytes. So that's very nice as well, I think.
Yeah. Yeah, I can see tons of use cases, even for me to use Babashka pods as a library in my non-Babashka Clojure JVM project. The first use case I have in mind is to interact with LibreOffice to convert documents into PDFs, for instance.
Yeah. Yeah. So is there a library like Apache Poi or something that can do this?
There is, yes, there is something like that, but yeah, it might be easier to just shell out and use another command for that, an application that does the job already without diving into the code.
Yeah, you can already shell out from Babashka to other programs. It's just that pods make this more like idiomatic so you can call them as functions.
Yeah, indeed. Cool.
So any more questions or?
Yeah, I was wondering, so if I'm understanding this correctly, pods are executables and not necessarily libraries. I was wondering if there are any plans, or if you have any thoughts in making some kind of dependency manager, or like a deps Eden for Babashka that you could use as to pull in pods instead of because now you have to manually install pods, if I understand correctly, and add them to your path. So do you have any ideas for that, or?
No, I haven't thought much about that. So what I'm doing right now is I distributed 3 pods, or 2 or 3, via Brew. So you can install them via Brew install, and maybe in Brew you can also declare dependencies on other things, right? I think so. So maybe Brew is like very much suited already for this kind of thing without reinventing new package managers. I don't know.
Can you
But
choose builds for with Brew, like which for the log
you
file?
can. Yeah, you can. You can. Do you mean operating system or?
No, I mean because I think Brew works with Git repos, if I understand correctly. And can you choose which commit hash you pull in, or does it work with releases? Or
yeah, I don't know. I haven't actually looked at that much. So this is just the beginning. So if you have any ideas,
Brew would be pretty interesting because it also works on Linux. So these days,
yeah.
But I think the fact that pods are using binaries allows you to use whatever distribution channel you want for your binary, being it Homebrew, being it apt-get or Chocolatey for Windows, whatever you want, and that's actually good.
Yeah, and actually they don't have to be binaries necessarily. Am I still sharing my screen? Yeah.
Yep.
Because there is also an example of a Python pod. Let's see examples. Oh, let's go here. Oh, yeah. So examples, and there is pods. So there is one Python pod as well. So it's just a Python script where you can interact with SQLite. So just as a very simple example, and Python has very good startup time as well. So this is an example of something that isn't binary, but still can implement like the pod protocol. So yeah, I don't know how you would distribute this, maybe as Python library or something. Yeah. Or Python, yeah, I don't know. Or maybe you can also distribute this as something in Brew, like Brew install this and that, and then you get this Python script on your machine. I don't know.
Yeah, you just have to make sure Python is installed, but that's it. And maybe Brew will even install Python for you if you declare it as a dependency. So I think it should work with Brew at least.
Yeah, so there's plenty of room to think about stuff like this, but it's still at the beginning. So yeah.
But I think it's a very cool project. So thank you very much for sharing it. I'm most likely gonna use the pods library from my JVM project soon. I can see that happening very soon.
Cool. Yeah, and the nice thing is if you implement pods for your JVM projects, they can also be used from Babashka. So it is like very useful for both worlds, and that's also nice to see.
Yeah.
So that's it, I guess.
Any more questions to Michiel? Usual 3 seconds. 2, 1, and we are good, I think. Again, thank you so much for presenting the yet another creation out of your hands. I really don't know how you managed to find 48 hours days, but congratulations on that.
I had a week off last week, so that certainly helped.
Indeed. All right. I don't think we have anything else more on the agenda unless somebody wants to step in to share something awesome. And I'm starting to build this 3 seconds delay in my brain, so that's expired. All right, so we are through for the Meetup tonight, I believe. Thank you so much for coming, joining us here online. Again, the recordings will be published on YouTube as soon as possible, most likely within today as well. And that's it for me. To the next time, I guess. I think it's going to be another online meeting again in June. So stay tuned for the update. And thank you so much again.
Thank you for hosting.
See you guys.
Bye-bye.
Thank you guys. Thank you so much.
Bye.
Bye.